All right, this will be a CO2 preheater test after I just revamped the system here and mounted the 2 times 12 gram Umrex uh, tank to the top of the gun to balance out the weight a little bit. It was kind of felt heavy having it to the side. It feels much more balanced now and lighter. So we're going to repeat the test, the heating test. And I have a Bluetooth um, temperature sensor installed inside the 2 times 12 gram CO2 by Umrex. We're going to turn on the controller for the CO2 preheater. This is the Gen 2 preheater on what I'm calling the X68 Stormtrooper 2.0 build. Okay, we have the 12 volt green power on LED. Starting temperature inside the 2 times 12 gram is 74 degrees Fahrenheit. And we have the heat active. LED, red LED is on. Power is going through the thermal switch, which is set at 40 degrees Celsius to trip on and off. The prior installation of this device was basically cycling every minute and a half to 2 minutes on and off through the heating cycle. So we'll see. The goal is to get up to the internal sensor up to 100, 105 degrees, no more than 120 ideally, in order to preheat the CO2 before they're punctured, which in previous tests have yielded a 200 psi increase by doing that. So we'll see how this test goes. And we'll get through 4 cycles. Once we're done with 4 cycles, I'll end the recording. That should be satisfactory. And let's see what we have now. I have to keep resetting this darn thing. It keeps going dormant. We're at 75 degrees internally. The ceramic heating element is sitting at about 250 degrees Fahrenheit. I don't know if you can see that or not on the camera. $230, $238, heating up. We still have the heat active LED on. The front of the 2 times 12 gram Umrex cylinder is sitting at about 90 degrees and climbing. All right, so you can see basically where we're at here. The back of the cylinder is 98 degrees roughly. It's coming up. It's still in its first heat cycle. Let's see what we're in here. We've come up to 78. Okay, first heat cycle has completed. The red heat active LED is off. And we're sitting at 78 degrees Fahrenheit, 79 internal to the cylinder, CO2 cylinder. It should cycle the heater back on again once it drops down, usually to about, I think, around 98 degrees at the thermal switch. Which the thermal switch is still reading about 104 degrees. So once that cools down, we'll see it'll activate the heating circuit again. Internal temperature is still coming up even though the heater's been turned off by the thermal switch. We're at 82 degrees Fahrenheit internal temperature. The outside of the cylinder is definitely, and as expected, is hotter than the internal temperature. We want to achieve an internal temperature of around 100 degrees, no more than 120, over the course of 4 cycles. As it warms up, the cycling should become a little more rapid. All right, we're at 85 degrees internal, and the thermal switch is still in its open position, 86 degrees. So we're still getting some transfer of temperature from the thermal device here, the heating element, the ceramic heating element, and the actual aluminum cylinder. The aluminum cylinder is acting like a heat sink, so it's drawing, even with it off, it's still pulling a lot of that heat. As it cools off the external cylinder, that heat's getting drawn into the chamber where the CO2 cartridges will reside and where the sensor is currently residing, the Bluetooth sensor. Let me take a reading of the thermal switch. Showing about 95, so I would expect that to complete the circuit again and go heat active any moment now. 95, 96 degrees at the thermal sensor. I'd show it to you, but I can't angle this laser gun in that direction. The thermal sensor is actually a thermal switch, which controls the operation of the preheater, is actually on the other side of the cylinder here. Hopefully allowing a complete thorough internal heat before it shuts off. Yeah, we're down about 92, 93 now. It should be kicking back on at any point now. There it goes. Okay, so it kicked back on at about 93. 92, 93, it kicked back on. So we're starting now our second active heat cycle. And we're just going to run these heat cycles. I expect it'll probably take 4 heat cycles before the internal temperature is stabilized at 100 and 104 degrees. We're at 91 degrees now, internal temperature. And we're in our second heat cycle. The idea of this circuit is to do this before you puncture the 2 times 12 gram cylinder. You want the cartridges to be at a good 100, 104 degrees before you puncture. If you do that, then they'll be under much higher pressure. Just like kind of like in the summertime, if they're sitting in the sun and you use a CO2, it tends to have a lot more pressure. So that's the whole point of this circuit here. We're up to 92 Fahrenheit internal temperature in the cylinder. It's not meant to quick heat in the sense that it would be able to heat the internal CO2 cartridges, within like 60 seconds or something. I would have to put a crazy big heater, and even if I did put a larger heating element or multiple heating elements, the problem you would have is how much heat the aluminum cylinder can actually conduct. Of course, I don't know the exact science of how much this particular thickness of this aluminum can conduct, but through my previous tests and the test today, if we're able to get 4 cycles each consisting of maybe a minute and a half or so, in order to get the internal temperature up to 100 degrees, then that's kind of perfect in what the goal is here. I already achieved it in the previous design, and like I said, I gained like 200 psi using it. Also, even after you puncture the CO2, if you leave the heater and let it just automatically cycle on and off, what it does is it'll kind of, what's the word I'm looking for? It kind of counteracts, maybe, I don't know if that's the best word to use, but it kind of counteracts the refrigerant properties of the CO2. In previous tests, what it was doing. Oh, actually, I missed it, but the camera did it, I'm sure. You can see our heat active LED went out at some point. So we're waiting for it to cool down again. The external cylinder is at about 102. The thermal switch that's controlling the whole circuit operation is about at 99. So once it gets back down around 93, it should reactivate for the third cycle. And we're about 10 minutes into this complete test. And the internal temperature is sitting around 96 degrees. So we're getting there. We're almost there. Once it gets to a consistent 100, 104 degrees, at that point, I'll be satisfied with this Gen 2 CO2 preheater. As I was saying, yeah, the whole point is not to rapidly heat it up. It's just to kind of preheat it so that when you're in, colder temperatures, you're not shooting out in the summertime, you can get the advantage and kind of overcome that refrigerant, the refrigerant properties that we have with CO2 that limits us from cold weather shooting. I haven't tested this outdoors yet, but I have tested it consistently in a 60-degree ambient temperature down in the basement. And its yields, like I said, it yielded some good numbers, gave me a 200 PSI increase. That was a Stormtrooper test number 4 final. I have a video on that under the playlist for the X68 Stormtrooper. 97 degrees is what it's holding at right now, and the no active heat cycle. While waiting for the third heat cycle to activate, explaining some of the circuitry. The control box basically takes 12 volts in from a small lithium-ion battery pack, 12-volt battery pack. That 12 volts first comes into the controller. It goes through a fuse, 4-amp fuse, and then from there, it goes into the on and off switch. And then after it goes through there and the switch is turned on, then it goes up to the thermal switch. Thermal switch is normally closed, rated at 40 C. It will open the circuit at 40 degrees Celsius or 104 degrees Fahrenheit. So it starts activating the heater right away until it reaches and senses 104 degrees Fahrenheit or 40 degrees Celsius, in which time it will open the circuit. Now, in addition to the thermal switch doing that on the output, okay, here's heat cycle number 3 is activated now. You can see the red LED. Going back to the circuit description, on the load side of the thermal switch is the wire that goes to the positive wire that goes to the actual ceramic heating device. Additionally, there is also another wire that comes back down into the control unit and comes into the heat active LED. This way we have indication of when heat is active or the thermal switch is working. Gives you a visual reference so you know if it's working. Just like the green LED gives you a visual reference that you know you have 12 volts power. And you can also discern that as long as you got the green light on, you do not have a blown 4-amp fuse in the controller box. So, sorry, a little long-winded with that. We're at 97 degrees Fahrenheit. This is the third active heat cycle. Let's see what we got over here. This is not the same ceramic heating element. It's a second one that I got when I ordered a 2-pack. So I needed to test this as well and make sure that the second one indeed worked. Hey, it looks like it's working good. I mean, the contact point of that thermal heating element where it mates to, okay, third heating cycle just kicked off. So the contact point where it mates here to the 12-gram CO2 chamber, during the heating cycle, we're at about 250 degrees Fahrenheit. So plenty of heat. And that heat's being drawn, by the aluminum cylinder. It's being drawn, like I said, it's acting like a heat sink. So it's drawing that heat right into where we want it. It's targeting in there. We're at 98 degrees Fahrenheit, and we've had 3 heating cycles. Once we get up to temperature, the heating cycles will cycle much faster. So the initial time it takes to preheat, yes, you got to give some thought to this. It's not something you're going to turn on and start shooting right away. Okay, we're at 99 degrees now. It's something it's going to take 10 or 15 minutes. What you do is you get yourself ready to shoot, get everything you need. You turn this thing on, let it preheat. Once it's got the internal chamber at a good 100 degrees or so, it's going to start cycling a lot faster. You're going to see it turn on and off. You can see this in some of my videos where I was shooting, and you could see the active red LED would cycle on and off quicker than it does now. So now we're at 100 degrees Fahrenheit. So that's the target right there, 100 degrees. Okay? And we just turned off again. Now, because the thermal switch is basically rated for 104 degrees, it will break or open the circuit at 104 degrees or 40 degrees Celsius. This should start cycling more rapidly. But for today's test, this video is long enough. This basically proves the point. One, the new heating element, ceramic heating element, is functioning just fine. Like I said, that was new. Also, the new 40 degrees Celsius thermal switch I had also replaced on this 2.0 version. Okay, so anyways, that's how it works. It's pretty basic. The lithium-ion battery pack is one of the smaller ones. I think it's like, I don't know, I think it's like around 2,300 milliamps or something. It's not very large. We're up to 101 degrees, so we're still climbing a little bit, even with it off cycle. Using this thing, I've had not yet once depleted that lithium-ion battery pack. I could probably even go with a smaller one if I could find a physically smaller one. It seems to be very efficient, and some of that is because of the nature of this ceramic heating element. It's naturally, as it heats up, it naturally, what's the word I'm looking for? Its internal impedance naturally increases with temperature. And what that does is that allows the current to stay low, so it runs more efficiently as well. It's able to produce a good 250 degrees of Fahrenheit, and it's able to do that continually while it draws less than, I think it's like maybe, it's under an amp. You know, I got a 4-amp fuse in there just to protect anything from short circuiting, just in case, you know, I didn't want stuff burning up on me. But yeah, we're at 101 degrees. That should maintain it pretty much. It should cycle through. Like I said, once you, right now it probably won't cycle that rapidly, but once the if there was CO2 in there and I was to puncture it now, the refrigerant properties of the CO2 would probably cool down the cylinder. You know, obviously it would cool down the cylinder, and the heater would kick back on and it would just maintain. But this is all warm to the touch, even though it's not in an active cycle right now. I wouldn't touch this when it is, though, because this will burn you right here. Doesn't seem to be overheating any of my other cables that are wire harnesses that are pretty close to it. All that heat's coming up and going into and transferring through the heat sink. Yeah. All right. I'm satisfied with this. I'm going to end the test now. And the next thing we'll be doing is checking it for leaks, since I just rebuilt this whole thing. And if she's leak-free, we'll be doing a test fire video next. Thank you for watching.